So Daria had asked, what is a derivative the other day? And I really wish she was here for this. It is that instantaneous rate of change at one point, or the slope at one point, right? And commutative notations, this is kind of fun. This is something new for us. This means the derivative, f prime of x. This is how we say, I want you to write this out. This is how you'd say that is f prime of x. What? Now, this is going to become second nature for us. One little apostrophe means a lot. Because how would we have just said this? F of x, right? This is f prime. This is f prime of x. If you just call this f prime, totally fine. Anyone have any idea what we'd call this one? Double prime. What about this one? Triple prime. And then beyond triple prime, you just say the fourth derivative, the fifth derivative, things like that. So that's just a fun little fact. All of these are different ways just to say the derivative. But how do you say this next one? This one you literally just say dy dx. That's all you say. Dy dx means derivative. This is new stuff, Stevie. Pays attention. This one, anyone have any idea? Y prime. This guy over here is just kind of a little redundant. It's kind of putting these together. This is just saying take the derivative of f. So d dx of f of x. I'm not even going to write it out. It just means find the derivative. So yesterday, and the 2 days, Monday and Tuesday, we learned these 3 different limits to find the derivative, to find that slope at the one point. What I left off of these, I apologize. We need the limit in front of it. So if you would write the limit as h approaches 0, that should be right in front of this. Silly me. Sorry about that. You guys, don't you think these two look pretty similar? Yeah. This one doesn't have an h. So what would I say instead of as h approaches 0? What do you think about this one? As change in x or delta x approaches 0. Just wanted you to see. I think a hard part of calculus is there's a lot of symbols, you know? And then this one was our second limit, and that's as x approaches a. That's it. If we look at this graph, x squared minus 4x, it says, hey, go find the derivative. It wants you to find the slope. Did I ask at a certain point? I didn't. I want the slope at any point, at any x value. So we're going to use this limit definition to find the slope of this curve at any x. Again, I apologize. I left off. Could you throw the limit as h approaches 0 in front of that? Gosh, I was too bothered by this. I wanted to know, as long as I find the limit of this, that will get me the derivative or the slope at a point. Okay, so you guys, let's go write that real fast. We got the limit as h approaches 0 of f, instead of f. Here's my function. Could anyone, Sorry, doesn't know what these are. Plug in my x plus h to my function for me. Go find me f of x plus h. Greer, help me out. How would I do that?
All right, so
we're going to just write it out. Don't distribute it or anything.
So it'd be f of x plus h minus x squared minus 4x.
Okay, so I want that. You agree. You said my function is x squared minus 4x. I agree. I need you to go plug x plus h into my f of x. Yep. So what would that look like?
X squared.
I'm going to even do this. Well, let's just write it before you distribute it. So it'd be x plus h squared minus, close, 4 times x plus h. Then, Greer, you said, how do we subtract f of x? If this is f of x, how would you write that?
X squared minus 4x.
Yeah. Do I need to put that in parentheses? Yeah, I do, because we got to subtract the whole thing. All over? H. Okay. Okay, here we go. You guys, Care Bear, you got this. You ready? X plus h squared.
X squared plus xh plus xh plus h squared.
What would 1xh plus 1xh get me? Perfect. 2 xh's plus an h squared. Thank you, Carrie. Finish the top. Finish writing the top out for me, Sammy.
Negative 4x minus 4h.
Keep going.
Minus x squared minus 4h.
Close.
So negative x squared plus 4h.
Yes, and that's why those parentheses are crucial. All over h. Good job. Does anything cancel out nicely?
Yeah, we got the 4.
Ooh, x squared's out, 4x is out.
Yep.
What are we left with? How are we doing with writing there? Braddock, you're doing better today. We got a 2xh and an h squared minus a 4h. Graham Nels, what would I notice with all of them?
They all have an 8.
Boom, 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 boom. And Nels, if they didn't, when I plug in a 0 here, I'd still have 0 over 0. So that'd be the problem. So them all having an h is crucial. So the limit as h approaches 0, I have 2x plus an h left. Oh wait, minus a 4? Whew. So do not be scared. Nelson, if I put a 0 in for h, what is left? Write everything that's left.
2x minus 4.
Nels, guess what you just found? You just found the derivative of this function at any x point. Now let me say that again. You just found the slope of this function at any x coordinate. And I'm going to talk to you about what that means. So if we think about calculus before, everything pre-calculus was straight lines. If you had to find the slope of something, it was just a straight line. This represents the slope of that parabola at any point. So let's go find the slope at certain points. Right here I said, hey, go use that derivative that Graham just found us, 2x minus 4, and find those instantaneous rates of change or those derivatives at these different x values. So let's go take a peek. I'm going to write out my f prime of x. You guys have never had to write that yet. F prime of x was 2x minus 4. Let's go write that. That is going to be the first of many f primes that you're going to write. Let's go find f prime of 0. That was the first thing I asked over here. You guys, where do you think I'd put this 0? Just like we did when it was f of x. That's great. What's 2 times 0 minus 4? Negative 4? You guys, at 0, let me put it in black. At 0, does it look like my slope is a pretty big negative, like negative 4 seems legit? Yeah, agreed. Okay, let's go find f prime of 1. F prime of 1? Negative 2. If I go to f prime of 1, that's here. Does that tangent line look a little bit less steep? Still negative though?
Yeah.
F prime of 2. Good. Would you say at 2, the slope looks 0 of that tangent line?
Yes.
Yeah, because it's a horizontal line. What about at 3? At 3, we got 2. Legit?
Yeah.
Yeah. And as we get to 4, do you think it should be the biggest?
Yes.
2 times 4 is 8 minus 4. Okay, what if I asked for the slope at 20, when x is 20? What we get? As we keep getting steeper on my parabola, do we think that tangent line is going to keep getting steeper? Yeah. So this is fancy. Now, does anyone not like doing this? I don't. This is not enjoyable to me. On Friday, maybe Monday, we're going to learn how to jump from this to this in one step. You're going to be doing that in the back, like the back of your hand. This is so quick. Nope, you're going to do it mentally. It's so quick. Thank goodness. We aren't going to have to keep doing this, okay? I don't blame you. Let's do it. Okay, this one I want us to use the different derivative function. I left this out. I need the limit as x approaches a to be in front of that. So sorry. So, did I ask you what's the derivative at a certain x coordinate?
No.
I did not. So I don't know what my x coordinate or my a in this case is. I don't know what it is, so we're going to just leave it as a. We're going to be very general. So how would I say, so everybody, we got the limit. Hey, Mr. Belk, how are you? Okay, so guys, let's earn them. We're finding that limit, but I'm being very vague right now, right? I didn't ask for that certain point. Seamus, I feel like you want some gummy bears. Shane, what is my function? What function did I give you? Yeah, what is it? What would we say my f of x is? I love it. Seamus, did I tell you a point that I wanted this derivative at? No. I didn't. So how would I say f of a? How could I, if my f of x was root 3x, what about f of a? Yeah, I know, it's kind of uncomfortable because we've got so many variables. So many variables. Shamey, on the bottom, again, we just left our x. So we've got x minus, what would we want to say for that a? We get to just keep it, guys. We get to just keep it. Okay, you guys, what happens if I plug in an a now? Root 3a minus root 3a over a minus a.
0.
Colin, we're not down with that, right?
Yeah.
Anyone have any ideas what I could do?
Conjugate.
Bondi, talk to me. You said conjugate.
3x plus 3a.
Root 3x, say that one more time.
Plus root 3a.
Perfect. Guys, a lot of times we're often used to the conjugate being on the bottom. It doesn't have to be. It's wherever our square roots are, and here it's in the numerator. Root 3x plus root 3a. Okay, Bondi. Okay, let's earn them. Let's earn them. Who's got root 3x times root 3x? Go ahead, Stevie. Love it. So I'm going to keep my limit notation. We got 3x. Keep going, Stevie. Why do we love the conjugate? Stevie, what's root 3x times a root 3a? And then that's kind of ugly, but then I have a negative root 3a times a root 3x. Oh, we love it. We love it. And then, Stevie, negative root 3a. It's just 3a. What do I put in front of it? So, sorry, negative root 3a times a positive root 3a. Perfect. All over, Stevie, I'm just going to tell you, don't distribute that out. Leave them separate. We got our x minus a over our root 3x plus root 3a. You guys, if I put an a right now, Graham Nelson, if I put an a, I'd have 3a minus 3a over a minus a. Thanks, Soph. She's saying let's factor out a 3. What would I have left on top, Soph?
3x minus a.
Ooh, Sophie, does this make you a little warm and fuzzy inside when you see that and that? Warm and fuzzy. Because I got an x minus a on the bottom as well. So now we know life is good. We're getting rid of our whole. Where she's saying, bye. Guys, we got the limit as x approaches a. What's on top, Soph, once we get rid of our whole?
3.
Over.
Root 3x plus root.
Beautiful. Guys, I think that this is a little funky. They're so little, they're bear cubs. As x approaches a, this would turn into a root 3a.
2 root 3a.
How'd you know that? 1 root 3a plus 1 root 3a?
2 root 3a.
Agreed. So we got 2 root 3a's on the bottom, and my 3 is on the top. Greer, fabulous. It's uncomfortable. That's hard. You guys just found the derivative of this function. What? You guys just found the derivative of root 3x. Let's take a peek at that graph one more time. There it is. The derivative. And what's the derivative again? We just found the slope at any point. It's like, okay, so here's the slope at any point. What's this a? This a is just an x coordinate, okay? We're going to have lots of different variables this year. Let's go use that. What I'm asking next is use that derivative to find the instantaneous rate of change, the slope, at these different x coordinates, guys. Let's go do it. I'll leave that graph right there. So if let's go write our derivative. Mr. Belk, this is the first time that we're seeing the notation f prime, which is pretty fancy. We got 3 over 2 over root 3. We could put that as an x or an a. I made this an x, so I should make that an a. If anyone wanted to do f prime of a notation, that's fine as well. Same diff. What are we going to find first?
They just have to match.
They just have to match, exactly. So f prime is 0. Let's do it. F prime of 0. 3 over 2 root 3 times 0. Talk to me, Lila. How'd you get undefined?
Because the 0 multiplies everything on the bottom.
Yeah. And when I've got 3 over 0, don't forget, we're finding our slope, Li. What's 3 over 0 going to simplify to be? I think you already said it.
Anything over 0 is going to be a multiple.
Exactly. So, Lila, let's go look at that picture one more time. To find the slope at 0, look at this funky square root function. What do you think that tangent line slope would be?
Doesn't exist.
The tangent line would look vertical. Yeah, Care Bear?
So see, the x on the denominator like not in the square root, or is it?
Oh, sorry, it was. That x in the denominator, if we go back up here, I feel like mine shorted out a little bit, so I apologize. It should be like this. Boop. That whole thing should be.
Okay. And then, so,
You guys, does it make sense that that tangent line of that graph looks vertical and a vertical line has an undefined slope?
Yes.
Yeah, agreed. What about the slope when x is 3? Let's go find f prime of 3. I'm going to go plug in a 3. You with me, Stevie? I'm going to go plug in a 3 right here. So we got 3 over 2 root.
9, which is 3 times 2 is 6, 1/2.
Whew! Okay, human calculators, I love it. So you're telling me the slope when x is 3 is a half. Does that seem legit? Is it positive?
Yeah.
Not too steep?
Yeah.
As we keep going to 12, do you think that we're going to get bigger or smaller?
Smaller.
Smaller slope? Let's go check. When x is 12, f prime of 12, 3 over 2 root 3 times 12. Did I pick those numbers on purpose?
Yeah.
Sure did. Square root of 36 times 2.
6 times 2, 12, 3, 12, 1.
Perfect. Is 1/4 less than a half?
Indeed.
We were thinking it was going to be less than, and it is. All right. Last one. F prime of 27. We're plugging 27 into my derivative. Whew! 3 times 27?
81.
81. Square root of 81. 9 times 2. 3/18?
1/6.
Beautiful. Gosh, that makes me weep. Does this one look familiar, people? This right here? Yeah, that point slope form. We talked about that a lot last year. AP calls that the little kid version. And do you think that we're ready for the big kid version? Are these the exact same thing? Talk to me. What's f of x fancy for? Y, right? Could I just say instead of x, I want to use an a? Sure. And as long as, kind of so like we were saying before, as long as we stay consistent. My x coordinate is an a here. What is this f prime of a? I heard it. I heard it's the slope, right? F prime is just, it's our new way of saying slope. So these are identical. Dice, did you have a question, buddy?
No.
Okay. Oh, I got you. Okay. So you guys, here we go. I need the equation of the tangent line of this cute little function when x is 6. Let me show you what this function looks like. X squared minus 3x. Boom. Here it is. I want the equation of this tangent line when x is 6. What do you think? Will the slope be positive or negative? Here's 6.
Positive.
Positive. What do you think my y-intercept will be of that tangent line? Positive or negative?
Negative.
It's going to be something negative. Let's go see if we can do it. Again, this is new for us. Bear with me. Here we go. In order to use point slope form, we need a point and a slope, right? And our slope is this whole new derivative thing that we've been learning. Maybe we just get our point first, though. If x is 6, how could I go get my y? Yeah. Where would I plug that in?
X squared minus 3.
You got it. You're saying, all right, well, if f of x is that, f of 6 would just be 6 squared minus 3 times 6.
18.
Thanks. I think the crazy thing is, this is so different than this now. And we just learned this apostrophe. These are completely different things just from apostrophe. Let's go find that derivative when x is 6. Let's remind ourselves, I'm going to just write down blue real fast. The limit as h approaches 0, f of x plus h minus f of x all over h. Okay, did I tell you what my x value is here? I want the slope at that point, so I know what my x value is. So I'm going to go put that boop right here and boop right there. Oh, golly. Here we go. Guys, I need to plug in my 6 here. I say let's set it up. Let's just set it up that f prime of 6 would be the limit as h approaches 0 of f of, let's just put our 6 in. I'm not going to plug it into my function yet. I just kind of want to map it out. F of 6 plus h minus f of x all over h. Now, let's get some gummy bears, people. Who can help me just plug this in? Where is my 6 plus h going? How would I write that? Go ahead, Dicey.
Into the square.
Yeah, you tell me what I'm writing down.
F of, or no,
It's okay.
6 plus h
Mhm.
squared.
Beautiful.
Minus 3 times 6 plus h all over h.
That was this part. Great. Don't forget, we got to do this part. Minus f of 6.
Oh, yeah.
So we're going to do minus.
Uh,
What would f of 6 be? Look what we already did.
6 when dt.
We could just go put in our value that we already found, right? You agreed, Dicey, that f of 6 is 18?
Yep.
Love it. And you said all over h. Help me out. Hetler, you want to do a little 6 plus h squared?
Sure.
Sure. Listen to that. Thanks for being open. 6 plus h, square it, buddy.
36 plus, plus 6h.
Yep.
Plus 6h.
Yep.
Plus h squared.
Perfect. 6x plus 6h plus 6h gets me.
12h.
Love it. Plus my h squared, right? Beautiful. Hetler, I'm going to have you keep going. Keep going, keep going. Keep distributing that.
Negative 18.
Yep.
Minus 3h.
And then,
Minus 18.
beautiful. Guys, when I did this in my last class, I got so nervous because I was like, oh no, these are opposites. They're not canceling out.
36.
Whew!
Negative.
Good thing we got this guy up here. Psh, psh, psh.
Also, you gotta fix the h's. 12 and negative 10 minus 2h. Just 9h.
Guys, this input is great. This input is great. I'm going to just simplify what I've got so far. How many h's do we have up there? This is what you were saying, Brady. 9h. And an h squared? What do we love?
9 plus h. It's just 9.
You want to know why you said 8? It's because you're human. Don't worry about it. Don't worry about it. We're human. I'll take participation over silent any day. 9 plus h. As my h is approaching 0.
9.
Whew, and what the heck did we just find?
Slope at 6.
We found the slope of this cute little parabola when x is 6. You're saying when x is 6 that this slope of this tangent line that I can't really reach is 9?
Yes.
Yeah.
Okay, here's the coolest part. Let's go write the equation of that tangent line. Okay, you guys, we got to write the equation of that tangent line. This is the coolest part. What is ooh? I got 3 packs left, people. How do I write this? Don't forget, here's my point, and I could even write it as 618. And here's my slope.
Ooh.
Ooh. Go use point slope form. We got this. We got this. Y minus
18.
equals my slope of
9.
times
6.
it,
Or x.
x minus 6. Check this out. Look at what happens when I type that in. What? Is that the tangent line when x is 6? Sure is. How special? The slope of this tangent line is going to be up 1 over 2, rise over run. In AP Calc, they're going to be asking a lot of questions with these symbols now instead of words. So we just have to get acclimated with these symbols, which I'm here to help you do. Sound good? So you would, your homework packet, go over and over to the 2-2 page. I see you hiding that first page. I see you hiding it. Go do 2-2, but I'm going to be skipping the first 2 questions.
So we just have one homework.
No, because look, it goes on to this page.
Oh.
Yeah, it's pages 2 and 3, but you can skip the first 2 problems.